is correct. Point 4.
Hi everyone, today we will solve oral 6 questions. We will have 2 questions today, so let's start right away. In the first question, we are given the information about a person. She has $D available, and we know that she earns every year I dollars. We know also that whenever she spends some money, some D amount of money, she's getting or becoming LND happy, or getting a utility of LND. Her goal is to decide how much to invest and how much to spend for herself. And we know that whenever we invest $1, we get $1.1 in return. The goal is to get the maximum utility, or saying it in different words, getting the maximum happiness. As always, our first step should be deciding the stage, state, and decision. So stage, in this case, we are playing with years, so we will say year. Decision, basically the question is giving us our decision. We are trying to decide how much money to spend. How much money to spend. Let's call this an XT. And in order to make a decision, we need to know how much money I have available. So we call that AD. Last step in this problem will be to decide on the function, and in our function we are dealing with a maximum, so our goal will be to maximize the utility. Maximum utility. In recurrent problems, always we need to, most of the time, let's say, we need to define 2 different times. We need to define the end of the problem, and we need to define the previous years prior to the end of that problem. So in this case, we are dealing with 10 years. The end of problem is 10. So suppose we are at year 10. In this case, we need to determine our function. So f10 d10. Think about this. You are in the end of the problem. You are in the last year. You have already for 10 years been saving money. But you know that after this year, this is a crazy example, but let's say you will die, right? Do you care about saving any more money and investing any more money? No. You will say, next year I'm gonna die, so now whatever I have, I want to spend it for myself. So basically, the function will be LND. All the money you have, spend it for yourself, be as happy as you want to be. But we can have other possibilities if we are dealing in previous years. So t is less or equal to 9. ft dt, dealing with maximum. Okay, so we're dealing with maximum, and we have some possibilities now. Now you care about the future. You care about how much money you're earning, but also you care about saving money. So your function would basically depend on the future. So you will spend a certain amount for yourself, but you will invest the rest of the money so that you can get something in return. In that case, I can spend an LNC amount of money. So that's, I spent something, some decision, I made that decision. And how much money will I have in the next year? In the next year, I will have 1.1 D minus C. So I had D dollars available. I had D dollars available, right? And I spent C amount of dollars. How much money will I have next year? I will have D minus C. But I also know that every year I am earning I dollars, right? So plus I. Again, to summarize the question, we will spend C amount of dollars, and if I spend C amount of dollars, I will be LNC happy. And next year, how much money I will have? Next year, I will have D minus C, the amount of money I had minus the amount I spent. I will have D minus C multiplied by 1.1 because I invested that money and I got it back. And every year my salary is I dollars, so I get that much of money. And I need to solve this problem until I reach first year, until I reach F1D basically. This is the solution to the first problem. In problem 2, we are dealing with a different matter. Now we are trying to optimize a factory's work. In this problem, we are given the worker need basically. So for each year, for 5 years, we need this much workers every year. For example, the first year we need 15, second year 30, and so on and so forth. And I know that in the beginning of the problem, in this year, I have 20 workers. I also know that for each worker, I pay $30,000 each year. I pay $10,000 for hiring a worker. I pay $20,000 for firing a worker. And also I'm given that each year, 10% of the workers quit by themselves, so I don't pay anything for them. So 10% of them quit. The goal of this problem is to find the minimum cost of maintaining the factory and the workers in an optimal way. As always, we start by defining stage, state, and decision. In our case, stage is year, T. Our decision is how many workers to hire and how many workers to fire. This is our goal, basically. So, hiring and firing workers. And the state is the amount of workers that you need, the requirement of workers. So let's say available workers, W. And the goal is to minimize the cost of hiring and firing. So minimum cost. The question is asking us to find a way in which we minimize. It's not asking us to solve. The question is actually asking us just to define the equation and the function and leave it like that. So basically, we need to define some variables in the beginning. What are our variables? HD is the cost of hiring a worker at the beginning of the year, T. So cost of hiring a worker at the beginning of year. Then we can have another variable, which is the variable of firing a worker, cost of firing a worker in the beginning of the year, and so on. And last, we have W, the worker requirement. At the beginning of the year, so on and so forth. Now we need to define our function in which we will be able to solve this problem in a nice way. So our function will be ftw. It's going to be a minimization problem, as we said. And we are minimizing the cost of firing and hiring workers. Now we know that the cost of hiring a worker is $10,000. Also, I know that the cost of firing a worker is $20,000. Now, we need to think about salaries. How much salaries will you pay each year? So if you think logically about that, we can say that, okay, I have W workers. I will hire some people, so plus that, and then I will fire some people minus that. It's going to be the same in this equation. So we will say plus $30,000, the salary of a worker, and that's W is the number of workers you have now, plus the number of workers that you will hire, minus the amount of workers that you will fire. So this is how much expenses you will have every year. But now we need to think about the future. How many workers will you have in the future? How many workers do I have in the future? I will have plus ft plus 1. So in the next year, I will have this much workers. So I will have the workers that I hired plus 0.9 W, the workers I have, minus the workers that they fired. They were fired. So again, 0.9, what does it represent? We were saying earlier that 10% of the workers actually quit, right? So in this case, we are removing 10%, so 0.9 of the workers that we will have. This is our functions, but we have some constraints, and the constraints are simple. How many workers you can hire? You can hire more than 0. You cannot hire minus 3 workers. You can hire only positive number of workers. Also, how many workers you can fire? You can fire a positive number, 0 and above, but you cannot fire more workers than you have, right? So you can fire ft maximum of whatever workers you have. And how many workers how many firings and hirings and the number of workers you need to have each year? You need to satisfy the demand each year, right? So in that case, we will say the workers I hire plus the number of workers I have minus the workers that I fire should be larger or equal to the number that of the requirement of workers. So for example, here we were saying we need 15. So I need to have, if this is 15, I need to hire, fire, and have the workers at least 15 because I need to satisfy my worker demand, my worker requirement. And we solve the problem until F120. We have 20 workers in the beginning of the problem, and we are dealing in the first problem, so we solve backwards until the first year, and that is when they have 20 workers. I hope this was good for you, and if you have any question, please send me an email, and I'll be more than happy to help you. Good luck. Bye-bye.